Hi students, this is AJ sir. Let's study 9th standard ICSE Math, chapter 17, Circles, exercise A. Also, to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information. Let's start with some theorems which will be useful to solve the sums. Now, a straight line drawn from the center to bisect a chord which is not a diameter. Such a straight line will be perpendicular to the chord. So AB is a chord out here, O is the center of the circle, C is the midpoint of AB. So we can say that OC bisects AB. What this means is OCB and angle OCA will be 90 degrees. So this proof has to be practiced. It can be asked in exam. Next we have the converse theorem, that if we draw a perpendicular from the center of the circle to the chord, it will bisect the chord. That means if OP is perpendicular to chord AB, then definitely P will become the midpoint of AB. This is the converse of the previous theorem, but the proof of this need not be studied. Also, it's quite logical to say that a bigger chord is always closer to the center of the circle, and the smaller chord is always far away from the center of the circle. And the distance from the center of the circle is always measured by drawing a perpendicular. And note, if we draw a perpendicular from the center of the circle to the chord, it will definitely bisect the chord. Next theorem says that equal chords are equidistant from the center. So if OP is 5 centimeters and chords AB and CD are equal, that means OQ will also be 5 centimeters. Since the chords are equal in length, their distance from the center will also be equal. So this theorem has to be practiced, but its converse need not be practiced. We just need to know the theorem that if there are two chords and they are equidistant from the center of the circle, that means OP is equal to OQ, that means the two chords are equal. And the next theorem, so again this has to be practiced for homework. There is one and only one circle which passes through three given points which are not collinear. So if you have 2 points, then many circles can pass through them. I can draw many circles passing through both of them. But if there are 3 points, then only one circle can pass through all 3 of them. That's it. But what if the 3 points were collinear in a straight line? It's impossible to draw a circle passing through all 3 points unless you can draw a circle with infinite radius. But then imagining infinity is insanity. So let's start with the exercise. We'll be solving questions 2, 4, 6, 8 and 10. These are very easy sums. 8th sum is IMP. Let's start with the second sum. Read the question. Now we'll have to draw the diagrams in each and every sum since it's geometry. To draw a diagram, I suggest to use a bangle, which is more convenient than using a compass. So if you don't have a bangle, then buy one from the bangle sellers. Just ask them for a rainbow tinted circle of light, some lustrous token of radiant lives. The color of the bangle doesn't matter. It may be silver and blue as the mountain mist, or it may be golden like the fields of sunlit corn. In this sum, the given is not given. They've given us the measurements, but no labeling has been given, so we will have to state all of that. That's necessary. O is the center of the circle, chord AB is 8 centimeters and its distance, that is OC, is 3 centimeters. And whenever I say distance from the center, that means it is perpendicular. They've asked us to find the radius, which in this case is OB. Step 1, first of all, it's perpendicular because it's a distance, so it's a right angle triangle. CB will be half of AB, that is 4 centimeters, because perpendicular from center of circle bisects the chord. This is a reason we will use repeatedly in this exercise and beyond. So this is 3 and this is 4. So by Pythagoras theorem, we can find the radius, which is 5 centimeters. I'm not shown the calculations, but you should. I just remember it's a Pythagorean triple, so I directly wrote the answer. Now the fourth sum. Try to draw the diagram on your own. Here, there are 2 chords here. AB's length is given 24, but XY's length is not given. All these labelings are ours, so we'll have to mention all of that. The distance of AB is given as 5 centimeters and the distance of the other chord is given as 12 centimeters. They want us to find the length of the other chord. So first we'll find the radius, because the radius remains the same in all cases. So just like we did in the previous sum, we will find CB, which is half of 24, 12. Use Pythagoras theorem in triangle OCB, and then we find that the radius is 13 centimeters. That means even OY will be 13 centimeters, is the radius of the same circle. So again use Pythagoras theorem in triangle OZY to find ZY. So 12, 13, so I guess ZY will be 5, but you'll have to show the calculations. And how much will be XY? Double of 5, that is 10 centimeters. Why? Again, the reason is perpendicular from the center of the circle bisects the chord. Now the sixth sum, it has 2 parts. Let's do Roman number 1 first. Draw the diagram of that. Is it like that? They are parallel to each other, 2 chords. Unlike in the previous sum where I intentionally did not draw them parallel to each other. Because they are parallel to each other, that means if I add OZ plus OC, I will get CZ. That is the distance between the 2 chords, which is what they have asked us to find. So how do I find OC and OZ? Well, we'll use Pythagoras theorem twice. Radius remains the same. Lengths of the chords are given. Perpendiculars will bisect the base, and use Pythagoras theorem in the 2 triangles. Please write the given as it is here. Construction. The perpendiculars are our construction. We have to mention that. That was not mentioned in the question, but we need to draw them in order to solve. Note that I have used Pythagoras theorem once and then I have used similarly to find the other distance. Once you find the 2 distances, you add them to find the distance between the chords, which would be 15 plus 8. That is the distance here. But what if both the chords were on the same side, which is in Roman number 2, like this? If they are on the same side, then the distance between the chords CZ will not be 15 plus 8. It will be 15, that is OZ, minus 8, which is OC. So that will give you 7 centimeters as the answer. So Roman number 2 is just a couple of steps more with the diagram. But in exam, if they ask you only Roman number 2 to be solved, then of course you'll have to write all the given and the construction, and you have to show all the solutions shown here, Pythagoras theorem, etc. And then instead of the addition in the end, you have to show the subtraction in the end. But in this sum, we don't have to repeat it because we've already done it in Roman number 1. Now the 8th sum is the IMP sum. So read it carefully first. Always read the question first. And try to think on your own, how would you solve this sum? Ready? Okay, here's the diagram. I've just joined some points. First, they've asked us to find CD. Now when they said that OA is 15, which is the radius, OB is also 15, that means OD will also be 15. It's the radius of the same circle. That means in OPD, I can use Pythagoras theorem. But first of all, we'll have to prove that angle OPD is 90 degrees. So hence I mentioned that bisector from the center of the circle is always perpendicular to the chord. So this is a converse theorem we are using, converse of what we were using earlier. Here it was not given that this is perpendicular, it was only given that this is bisecting the chord, and we know if there is a bisector from center of the circle, it is always perpendicular to the chord. It's important to mention this because only then can we use Pythagoras theorem. And that's how I got PD as 12, and so CD will be double of that, which is 24 centimeters. Now in Roman number 2, I have to find AD. So again, I'll use Pythagoras theorem in triangle APD, where PD is 12 and AP is 15 plus 9, 24. So that's not a Pythagorean triple. So I'll have to actually calculate it. I got 720, so AD is root of that. Do prime factorization method. I got 12 root 5. Root 5 value you need to remember, 2.236. Even root 2 and root 3 you need to know. Root 2 is 1.414 and root 3 is 1.732. Only these three roots values you need to remember. And of course multiply and get the answer in 3 decimals. You may round it off to 2 decimals, but I prefer to leave it with 3 decimals. So that's how you got Roman number 2. Now Roman number 3 is CB. You have to find CB. Now clearly we'll be using Pythagoras theorem in triangle CPB. I have CP, which is 12 centimeters, we found it. But how much is PB? Well, we know that OB is a radius, which was 15 centimeters, and OP is 9 out of that. So subtract it. How much is PB now? That's right. It's 6 centimeters, sorry. So now using Pythagoras theorem, again, it's not a Pythagorean triple, so use the prime factorization. Again, root 5 is in the picture and you get the answer in decimal. You cannot leave the answer in root. That's not allowed. Or you lose marks. So always solve further. And then finally the 10th sum, which is actually the same as the previous sums. It's very easy. The diagram is also given. If the given is given, no need to write the given. They've given one chord and its distance, and they've given the distance of the other chord, and we have to find CD. So like which sum is this? It is like the 4th sum, exactly like the 4th sum. So first of all, we know that MB will be half because that's a theorem. So half of 24 is 12. Use Pythagoras theorem, so OB will be 13. So OD is also 13, a radius of the same circle. Again, use Pythagoras theorem to find ND, and I know that it will be 5. And then double it up to get the answer as 10 centimeters. Write the statements carefully the way I have written.